Hi everybody. So our agenda today is to work through two example problems, and then your homework is going to be for you to complete worksheet number 7. I thought we could start by actually looking at the calendar. So let's see. So here's what your calendar looks like, and here's kind of where we are. So the day before, the lesson was 533, and it focused on those. Actually, the last 2 days focused on those shortcuts of the altitude squared and the leg squared um, shortcuts and formulas. And today we're just going to do some more with that. So each of the two examples will practice those. Um, Worksheet number 7 was what you should have started with last night's homework. And then today is where you will finish that worksheet depending on where you're at. Okay. And then tomorrow there's another lesson with a few examples that there will be a video for. And then you'll have worksheet number 8 to go along with that. Okay. So let's see. So here are your examples. Oops, sorry. Here are your examples. Here's what the problem should look like. It says to find the value of x, the altitude of triangle BNS, and the perimeter of triangle SNU. So we have a couple things that we need to do. All right, so find the value of x. Let's do that first. So we want to start by noticing what kind of triangle this is so we know what kind of shortcut that we use, or if we can use a shortcut. We can see that this big triangle right here, triangle BSN, is a right triangle because of this right here. We can see that from this right angle, there's an altitude that is drawn. Okay, whenever that happens, that means that there are 3 similar triangles. So that's really important. We want to know when there are 3 similar triangles. So whenever we have a right triangle where an altitude has been drawn from that right angle, we're creating 1, 2, and then the third big triangle is our 3 similar triangles. Because we have 3 similar triangles, we can use specific shortcuts. Okay, so we want to find out what x is right now. Since we have 2, and I'm going to write them here actually. We have 2 shortcuts. We have altitude squared equals the left times the right. We also have leg squared equals the short times the long. You could also say leg squared equals the adjacent times the whole. They mean the same thing. Okay, so either of those. Given the fact that I don't have an altitude, I don't want to call this y because then I would have 2 unknown variables right now. I will have to find this altitude eventually, so I can call it y if I want to. I just don't want to use the altitude squared formula. Otherwise, I'm going to say altitude squared equals the left times the right, and now I'm going to have an equation with 2 unknowns. So I'm going to use this right here. If I look at my big triangle, this is the leg of the triangle. This would be the other leg, and then this would be the hypotenuse. Okay, so if this is the leg of my triangle, I can use this one. I'm going to use this one right here. I feel like this is an easier way to explain it. Okay, so I'm going to call this 1 right here. I'm trying to find the value of x. Okay, so it's the, and I'm going to write this out, it's the leg squared equals the adjacent side times the whole side. Okay, so the adjacent or the leg is my entire triangle. So for the big triangle, my leg is 6. So I'm going to say 6 squared equals the adjacent is talking about the side next to, which would be this, all the way to the point that it hits that altitude. Remember, adjacent means next to, so it cannot be this part over here. It can also not be this part because that's the leg of the big triangle. All right, so that's 4 times, and then the whole is talking about from here all the way. So the whole means the entire hypotenuse, and that would be the length of x squared plus 4 because I need to add those 2 sides together. So I need to multiply this by x squared plus 4. Okay, so leg squared equals the adjacent side of 4 times the whole side. Remember, add them, don't multiply. Okay, so if I simplify this, I have 36 equals, if I distribute 4x squared plus 16. Okay, I can see it's quadratic. There is only one of my, I only have one x squared term, so I can actually get it by itself. I do not need to move this over and try to factor. I could, just don't need to. So I'm going to subtract 16. That's going to give me 20 equals 4x squared. I'm going to divide by 4. And that's going to give me 5 equals x squared. Take the square root. And I get that x equals root 5. Okay, and there's one of my 3 questions answered. I can go back in now and label. So if this is square root of 5, would notice it's taking x and it's squaring it. So that means I'm taking square root of 5 and I'm squaring it. That means that this side right here is a total length of 5. If I square root, it undoes it. Okay. I want to find the altitude of triangle BNS. So BNS. So I want to find this length right here. So I want to figure out what y is. Okay, one way that we could do it is we know that for this triangle right here, triangle BUS, we have 2 of the 3 sides. So I could do a squared plus b squared equals c squared. So I could say 4, notice this right here is my right triangle or my right angle. So I could say this leg squared plus this leg squared equals the hypotenuse squared. Okay, and then that would mean that y squared equals, this would be 36 minus 16, which would be 20. And I'm going to take the square root of that. Okay, sometimes that's not an option to use the Pythagorean theorem, so I actually want to show you using one of your shortcuts. Okay, if I want to solve for y, you're going to see that we're going to find out this same value. So if I want to find this y, this is the altitude, so I can use this shortcut, this altitude squared equals left times right. So the altitude is what I don't know, that's y. So y squared equals, the left times the right is saying this from the point, from that 90-degree angle, times this, which I know is 4 times 5. So 4 times 5, oops, 4 times 5. That means that y squared equals 20. And notice that that's right at the same point as this. I take the square root, and notice I'm getting this exact same answer. This simplifies. This would be 4 times 5. Square root of 4 is 2, so that's 2 root 5 is an exact answer. I was trying to figure out the altitude. The altitude is a segment, so I'm going to say segment SU equals 2 root 5, or 2 square root of 5 is, let's see, 4.47. And this is measured in feet. Make sure you always have units with segments. Okay, and then the last question is to find the perimeter of triangle SNU. So SNU is talking about here to here to here. So I'm just trying to find the perimeter of this small triangle. Well, I already know that one side is 5. I just figured out that this one is 4.47 or 2 root 5. We can use either or. The approximate answer is fine. And then this one right here is the hypotenuse. Okay, I can use the leg squared. I can also use Pythagorean theorem. Okay, so let's say I was using Pythagorean theorem. It would be that this is my leg and this is my leg, and this would be my hypotenuse. So I would say, let's do it over here. I would say leg squared plus leg squared, and I'm just leaving it like this so I can actually talk about how to square this if you ever have to, equals c squared. So this would be 25. This, because this is multiplication, we can distribute it here, which actually gives us 4 times square root of 5 squared is 5 equals c squared. So this is 25 plus 20, which is 45, equals c squared. So c would be the square root of this. So this is the length of square root of 45. So for the perimeter, I'm going to say perimeter equals, it's going to be 5 plus 2 square root of 5 plus square root of 45, which could be simplified as well, but I'm going to approximate this perimeter anyways. So if I put that into my calculator, let's see. I'm going to get that the perimeter is about 16.18 feet. Okay, remember, X values we want is an exact answer, length of segments, perimeters, areas, approximate answers. It's more authentic. Okay. Okay. And you would have gotten the exact same answer if you said 4.47 here, and the square root of 45 is 6.71. So if you did 6.71 plus 4.47 plus 5, you still would have gotten this exact same answer. Okay, so let's flip over to the backside. In this one, we want to answer a couple questions in this one too. Notice that the diagram is not labeled, so we're going to have to label based off of what we're given. So we know that segment HA is 0.5x, so I'm going to say this is 0.5x. We know that segment AW right here is 4.5x minus 7. So always label your diagram first. We know that segment WK, which is this bottom segment, is, and I'm going to distribute this so that way I don't have to do it again later. So this is 4x minus 4. We know that segment AS, which is the bottom of this triangle, is x minus 4. Okay, everything's measured in kilometers, so I don't need to throw the units on here. See that everything's measured in kilometers. I'll use that for my answers. I want to find the value of x in the ratio of side AS to WK. So let's start with find the value of x. Okay, to find the value of x, I need to set up a proportion. The most commonly missed way to set up this proportion I'm going to show you is to say something like 0.5x over x minus 4, which equals 4.5x minus 7 over 4x minus 4. So since we're not in class to talk about this, I would write this down and then just draw like a line through it and say like not possible. Okay, and here's why. If we were to do that, that would be saying this. That would be saying this side length, so the left side of this triangle. So actually, let me show you the triangles first. So remember, these are our triangles. So we have that triangle, and then we have this big triangle. Okay, they're in the same orientation, which means that the lefts match, the rights match, and the bottom matches the bottom. Okay, so the problem with this proportion is 0.5x over x minus 4 is saying that I want to do the left side over the bottom, which is fantastic. There is a left side and there is a bottom. But then when I say 4.5x, I'm saying the left side over the bottom. But the reason that this proportion doesn't work is because this isn't the left side. AW is part of the left side, but this is the left side. So that's the proportion that I need to set up. So when I set this up, it's going to be similar, but I'm going to have to change one of these expressions. So I do want to do this left side over the bottom. So I am going to say 0.5x over x minus 4. I want to set it equal to the left side. So that means I need to go all the way from H down to W, not A to W. So that means that I need to add up, and I need this entire side. So when I add these two together, that means I'm doing 4.5x minus 7 plus 0.5x. When I add those two together, 4.5x plus a half x is 5x minus 7. Okay, notice that this is the difference, this expression. And then I still want to put this over the bottom, which is 4x minus 4. Okay, it's got to be the entire left side over the bottom and then the entire left side over the bottom. So from H all the way to W. Okay, this would be a good place to pause right now and see if you can cross multiply, see if you can get down to the quadratic, see if you can factor it, and then unpause it or fast forward through it as you need to check your answer. Okay, so let's assume you guys are checking your answer. Hopefully you are. When you cross multiplied, you should have been doing 0.5x times 4x minus 4, and then you should have been doing x minus 4 times 5x minus 7. And I would definitely write this out since you're multiplying two binomials together and they're not easy binomials because this 5x. Over here, when we distribute, a half of 4 is 2, and then be careful that you have your 2x squared. Over here, half of 4 is negative 2, and then we got to bring that x with it. Over here, we're going to get a 5x squared minus a 7x minus a 20x, and then plus a 28. Since this is my bigger term, I'm going to move everything to that side. So I'm going to say 0 equals, when I subtract 2x squared over here, that's what's going to give me a 3x squared. When I add these two together, that's going to give me negative 27, but then I have to add 2x here. So I have negative 27 plus 2, which gives me negative 25x, and then plus 28. Okay, so when I factor, I'm going to have a 3x, the x. I know that it's got to be minus minus because that's a plus and that's a minus. So if I think about my factors of 28, I would jump right to 4 and 7. If I put a, let's say, a 4 here and a 7 here, this gives me 12 and 7 more. So that would give me a 12, and then 7 more gives me 19. So that doesn't work. So let's say I flip them. I'll put a 7 here and a 4 here. 3 times 7 is 21. 4 times 1 is 4. Together that makes 25, so I know my factoring is good. My x values are going to be, I'm going to have to add 4 and then divide by 3. Over here, I'm going to have to add 7. And now both of those are positive numbers, so I want to check to see if both work or maybe if one doesn't work. Okay, 4/3, if I take 4/3 and I put it here and I do 4/3 minus 4, I'm going to end up with a negative number, so that one will not work. 7, let's see, if I do 7 minus 4, that means that that side's going to be a 3, so that works. 7 times 4 is 28, minus 4 is 24, so that works. I can see that from here to here, the scale factor is 8. Let's see, 7, half of 7 is 3.5. So that obviously works. If I do 4.5 times 7, I'm going to use a calculator for this, minus 7. So this one right here, I would get 24.5. And then I'm going to substitute it in here too, which remember was this expression right here. So 5 times 7 is 35. 35 minus 7 is 28. And if I go check here, if I add these two together, I get 28. So everything checks out. Okay, so x equals 7 does work. And then I'm going to come up here. I need to find the ratio of side AS to AW. A ratio is a fraction. So a ratio is a fraction. Whatever is listed first must be the numerator. So that means that my ratio is going to be side AS compared to side WK. Okay, so I just figured out all my side lengths. So side AS is a length of 3, and side WK is a length of 24. So that means the ratio of AS to WK, when I simplify this, is 1/8 if I divide both of those by 3. So this would be my ratio. Okay, and I believe that is it. That is it. Okay, so your homework for tonight is to finish worksheet number 7. So finish worksheet number 7. Okay, there's a couple short examples for the next lesson. Let's see. Let's see. Yeah, we're going to pick a few out of here and then go through them together, okay? And you can end this video right now. I thought I might go over at least, I'm going to go through one problem from your homework in case it happens to be one that you need help on. Okay, let's see. All right, let's look at number 7. So if you haven't done this one or if you need help with it, this will hopefully help. It says, what postulate makes the triangle similar? Find the value of x. So what postulate makes the triangle similar? Remember, postulates are your side, 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 your side angle, side, and your angle, angle, angle. Okay, in this case, remember that we have this triangle, and we also have this triangle. We know nothing about their sides, so we can't say, we know that one side is 5, but the other ones are all expressions. So side, 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 and side angle, side don't make sense. We do know that this angle is congruent in the blue triangle as well as to the yellow. So that's one pair of angles. Remember, if you know that this side is parallel to this side, then that must mean that this angle right here is the same as this angle right here. It has to do with those corresponding angles. Let me kind of draw it for you real quick. So this is your transversal if you think back to Math 1. This would be your parallel line. Notice that this angle is in the top right out of these 4, and this one is in the top right out of these 4. So those are corresponding angles, which makes them congruent. So if I get rid of all of this stuff, that's why these two angles are the same. So what postulate makes the triangle similar? It would be angle, angle, similarity. And because they're similar, I can set up a proportion. Okay, and this is pretty similar to the one that we just kind of went through. So notice that this is the left side and this is the bottom. So that means I would say 5 over 2x plus 4. Notice I'm not writing any units in here. I don't need yards, right? This is just, I'm setting up an equation, no units in an equation. Okay, and then when I go to say the left side over here, I want to make sure I don't say this. I want to say that I say the left side, so this whole thing. Okay, so that would be x plus 6 plus 5. So that means that entire length is x plus 11 over the bottom here, which is 10x minus 2. Okay, and then from there you should be able to cross multiply and you should be able to factor and simplify, figure out the value of x. Okay, I think there's any other ones. Let's see. So maybe something like number 12. Find the values of E and F and the length of segment CD. So let's see. Find the values of E and F. So E and F are right here. I can figure out actually the values of E and F in 2 different equations. So notice that I have this big triangle right here, right? This is my right triangle. My right triangle has a leg here and a leg here. So I can use that shortcut. So I know that this is a right triangle with an altitude drawn to it. So this triangle, and then this big one that I outlined are your 3 similar triangles. Because I have those 3 similar triangles, I can use the, leg squared equals the adjacent times the whole. And you want to be very careful that you use this in the appropriate time. I could not use it in something like number 11 because there are no right triangles, which means this triangle, this is not a triangle. There are no 3 similar triangles. It only works with 3 similar triangles. Okay? So my leg squared would be 6. So I would say 6 squared equals, my adjacent is right here. And notice it stops right at that altitude, so it would be E. And then the whole would be this length from A all the way to B, which I know is 10. So I don't actually want to say E plus F since I know that the answer is 10. So I would say times 10. And then I could say 36 equals 10E. I could divide by 10, and that's going to give me 3.6. So I just figured out the value of E. Okay, I can approach the triangle from the other side, and I can now use this as my leg. And I can say leg squared equals, this would be my adjacent. Notice it goes all the way to that altitude. So that would be my adjacent. And then my hole is, again, this whole piece right here, which is 10. Okay, and notice the hole is always the hypotenuse. So this looks like a big piece, but it's always going to be shorter than the hypotenuse because it's going to stop at the altitude. Okay, so that's going to give me 64 equals 10F, which means that F is 6.4. Notice if I added up 6.4 and 3.6, I'd have 10, which means really once I figured out that this was 3.6, I could have done 10 minus 3.6, which makes this 6.4. Sometimes it's nice to work it through and make sure that our answer is right. Okay, the last piece was asking for the length of CD right here, which is our altitude. So I'm going to call this X, and then I can use the shortcut of altitude squared equals left times right, which I couldn't do until I first figured out E and F. So my altitude I'm calling X, so X squared equals, the left I could call this right here, which is 3.6. And then the right would be the other piece, which is 6.4. So if I do 3.6 times 6.4, I get that X squared equals 23.04. I take the square root of that, and this is going to tell me that segment CD is about 4, oops, not about, it's actually exact, is 4.8 kilometers. And notice this is a segment, so it's got units with it. F and E were just variables, no units with variables. All right. Let's see. All right, so that should conclude that. Your homework is to finish the rest of this worksheet. Thank you.